Hello friends, in this video we will witness the visual proof of Pythagoras theorem. So what just Pythagoras said? Pythagoras said that the hypotenuse squared is equals to the perpendicular square plus base square. So this was the sayings of the Pythagoras. So if we see, this equation just holds on or just verifies a right angle triangle. So I have built a right angle triangle. I have drawn a right angle triangle just for you, so we can see a right angle triangle here, and which has the dimensions of the 4 centimeter and the 4 centimeter. Just name them A and B, and here is the C, which we will find with the help of the Pythagoras theorem. So I have drawn a 4 symmetric triangles, means they have the same dimensions. If I place these 4 triangles here in a way that the new geometrical figure has been formed, so we can see a new geometrical figure has formed, which is a square, because we have the dimensions are the equal, because this length is 4, this length is 4, this length is 4, this length is 4, and this length is 4. So it says that it has 4 centimeter here. 4 means 8 centimeter total length. It has a total length of the 8 centimeter, and this length of the total centimeter means 8 centimeter of this whole length, and here is 8 centimeter. And we all have the right angle triangles in between. We can see. Okay, so I have just drawn a big square for you, which holds this entire area. This is the square, which is the big square which holds the entire area. So we will just label it the big square. Okay, just put it aside these triangles. I have already drawn a triangle square with the triangles just for you, and label them A, B and C. So there is a one triangle I have placed, second triangle is here, third triangle is here, and the fourth triangle is here. So what we will do, we can see a big square has been built up, and we can also see that there is another square which is among these all triangles, which is this triangle, this square, which is among these all 4 triangles. So I have just labeled it C square, because here length is C and here length is C, because these all are the hypotenuse. This is hypotenuse of triangle, this is hypotenuse, this is hypotenuse, this is hypotenuse, which all are the C. So here it is C, C and C. So we can see that this is the C square, squared square. So this square has the dimension of C square, means C into C. So we can see that the area of this big square is equals to the area of these 4 symmetric triangles plus the area of this square among these triangles. Just remind that this area of a big square is equals to the area of these 4 symmetric triangles plus the area of this square. Just let us see these 4 triangles again and arrange them in different way. Means there is a one triangle here. The previous figure was like this. Previous figure was like this, but I am gonna arrange them, but I will not change the area of these triangles, but I will just arrange their alignments and the positions with the help of the mathematical laws, which are flip or slide or rotate. These 3 laws can be used to turn any figure, but do not change these dimensions. If I turn this triangle, rotate this triangle like this, and rotate this triangle like this, so I have built 2 new squares, because the dimension are the 4 by 4. and I place this square like this. So I can see these are the total area of the 4 squares. This area, this area, this area. Here I can see I have made 2 new invisible squares, which are A and B, because here is the A and here is the B. So we can see a new square has been built up, which has the dimensions A square plus B square plus the area of the 4 symmetric triangles. These are the 4 symmetric triangles, and this is the A square, this is the B square. This is the second case. In the first case, the area of the big square was the area of C squared square plus the area of 4 square triangles, 4 symmetric triangles. So this is the second case. Just remind these 2 cases. And we can also see this square is equals to this big square. So we can see that in both of the cases the area of the 2 squares is same. So we will do some algebra. So we can see the area of big square in first case was C squared plus 4 times of area of triangle. Why have we written 4? 4 just because these triangles are the symmetric. Just find out the area of one triangle and multiply it by with the 4, so we can get the area of 4 symmetric triangles. And here A is the dimension which is the perpendicular, it means height, and B is the base. So we have just found a new formula for the area of big square. And in the second case we have seen the area of big square was A squared plus B squared plus 4 times area of symmetric triangle. So these are the 2 equations has been built up for the area of a same big square. So we can compare these equations. Just compare these equations by area of big square in first case is equals to the area of big square which is same square in second case. Okay, so we can see that the area of big square in the first case was C squared plus 4 times area of symmetric triangles, and then second case was A squared plus B squared and the 4 times area of symmetric triangles. So 4 times symmetric triangle will be cancelled out on the both sides, and what will remain? C squared is equals to the A squared plus B squared. This is the Pythagoras formula, which holds the hypotenuse square is equals to the perpendicular square plus base square, which we can see in these dimensions. Here A is our perpendicular, B our base, and C our hypotenuse. So C square means hypotenuse square, and A square means perpendicular square, and the B square means our base square. So this formula holds for all type of the right angle triangles. There are different types of right angle triangle, which means their dimensions can be changed, but not there are different types of the triangles are not available for the right angle. Right angle triangle is a one type of triangle, but there are different dimensions we can use to form a right angle triangle. For example, there are many triangles are there. For example, I'm going to draw one here. If we say this is a right angle triangle, here is 3, here is 4, so this must be 5, because the 3 squared plus 4 squared means 9 square plus 16 square is equals to the 25, means 25 is equals to the 5 square. This side must be 5 square. If we draw a triangle with the help of the ruler, so if I draw perpendicular with the dimensions of the three units and the dimension of base are the 4 units, the dimension of this hypotenuse must be 5, otherwise this triangle cannot hold the property of the right angle triangle. So hope you like this video. Please do comment and subscribe my channel, and I will wait for your feedback. Thank you.